Okay, we're going to do example number 6. Okay, a 3 kilogram box. So we'll start on the free body diagrams. FBD. That's M1, and it's 3 kilograms. And a 6 kilogram box. So the free body diagram M2 is 6 kilograms. Is being pulled by 133.2 Newton pull force. And we'll draw both free body diagrams, find the acceleration and both tensions. Okay, so as I said, if this guy's pulling up with 133.2 newtons, that's transferred through the rope all the way to the block M1. So this tension here is still also going to be 133.2. That's what a rope's do. It just transfers that force as a tension force back and forth along the rope. 133.2 newtons. So let's draw our free body diagrams. So there is a pull force up, or tension 1. I'll call it T1 in this case. And that's acting on this object. Gravity is pulling down, but also T2 is pulling down on that block. So I'm going to draw 2 arrows here. One is going to be the force of gravity, and the other one will be T2. And that's acting on block M1. Block M2, I'll draw it as a little bit bigger block. Don't know why. Tension 2 is pulling up, and a force of gravity is pulling down. The system is accelerating, but we might not know which direction yet. Since we don't have the tension forces of T2, we will not work on individual objects. We'll start with the system. So I'll start with the system way over here. The mass of the system is 9 kilograms. Okay, and the forces of the system. Well, if we add up all the forces on the system, there's a tension 1 up. That's equivalent to the pull force, which is 133.2 newtons. And there's 2 forces of gravity down, minus the force of gravity down of object 1, minus the force of gravity of object 2. Well, let's do those quick calculations. The force of gravity of object number 1 is mg, and the mass of object 1 is 3 kilograms. G, being the gravitational field strength, is 9.8 newtons per kilogram. This is going to equal to 29.4. Okay, I'm going to do a little bit of an aside calculation here as well for the force of gravity of number 2. And that mass is 6 kilograms. And that's 9.8 newtons per kilogram again, gravitational field strength. And that will be 58.8. So let's use those calculated values, change the color just to show that. Force of gravity is 29.4 newtons. Subtract the other one of 58.8 newtons. So the forces, when all added to 133.2 minus 29.4 minus 58.8. Let's pull up Mr. Calculator. 133.2, subtract 29.4, subtract 58.8, 45 newtons. So the sum of the forces is 45 newtons. So let's write out Newton's second law. The sum of the forces, which is our F net, will equal MA. That means 45 newtons is equal to the mass 9 kilograms times the acceleration is 5 meters per second squared. A lot of work there to get that 5. But we're more than halfway done. Okay. I'm going to work on M1 because it has the most forces on it. We're going to be doing both of them. All we need to do really is one of them to calculate what tension 2 is, but I like doing the second one as a check. So let's work on M1 right now. And write out Newton's second law. The sum of the forces is equal to F net, which is equal to MA. And the forces, I'm going to erase it because I don't want to ruin my free body diagram, but the object is traveling upward. Why? Because when I did this, I assumed that the tension 1 was pulling high. I said 133 was positive, the other ones were negative. And it did turn out that the acceleration here was upward at 5. So this is upward at 5. So that T1's winning, the other two are losing. So T1 minus T2 minus the force of gravity is equal to MA. T1 we know is 133 0.2 newtons minus T2, we don't know that, minus the force of gravity. The force of gravity on the 3 kilogram block was 29.4. And that has to equal the mass 3 times the acceleration, which is 5. Whew, that's a pretty big calculation. I'm just going to move that over to the side just so that I know I'll be needing a little bit more room. So let's solve for T2. T2 is going to equal 133.2 newtons. Subtract the 29.4 and subtract the 15 kilograms meters per second squared, which is also a newton. So what's T2? Pull up Mr. Calculator. 133.2 minus 29.4 minus 15, 88.8. Draw my vertical line down here. I'm going to now do a check. I have all the answers. The check is just to confirm one of the answers as being true. So we're going to check T2, the last number we just did. You'll see, hang on. Sum of the forces is equal to F net, which equals MA. This is the simple one. Why? There's only two forces here. That's the pull force up minus the force of gravity down is going to equal MA. T2 minus 58.8 has to equal the mass, 6 kilograms, times the acceleration, which is 5 meters per second squared. So T2 is going to equal 58.8 plus the 30. So T2 does equal 88.8 again. I cloud it around. A couple check boxes. A nice smiley face, and oh yeah.